Welcome to lesson 4.7, mean absolute deviation, which looks like three random words that have been stuck together, but aren't. It's the last one, y'all. The last lesson of the year. Our target today is to find and use the mean absolute deviation to describe the spread of data. And those three seemingly random words that we've stuck together, mean absolute deviation, is the average distance from the mean for all numbers in a data set. How far is the mean from the numbers in the set? The smaller the mean absolute deviation, or the MAD, the MAD, the less spread there is in the data set. It means that the numbers are all close to the mean. So if you've got a set of numbers that are really clumped together, picture Samantha's movie watching habits from 4.6, her mean absolute deviation will be smaller than her buddies whose name I don't remember, who had a much more spread out data set with numbers up to 11, from 0 to 11. Samantha's was much smaller, and the other guy was much wider. So his mean absolute deviation, his MAD, would be much larger. When the MAD is larger, the numbers are more spread out from the mean, and there is greater variability in the numbers of the data set. So if you've got a small number of closely packed data points, you're going to have a very small MAD. If you have a large number of very spread out data points, you're going to have a big MAD. And I hope saying MAD is okay because mean absolute deviation will get tired after a while. I'll keep saying it occasionally. How to find the MAD? First, you got to find the mean in general, because before you can find how far numbers are from the mean, you have to find the mean. Then find the deviation from the mean for each data value. This is data value minus mean. So if we have a set of numbers 1, 2, 3, 4, 5, 6, and our mean is 4, which it probably isn't, we would go 6 minus 4, 5 minus 4, 4 minus 4, 3 minus 4, and so on. Then you would find the absolute deviation for each value. These are always positive. So if you remember absolute value, that's what we're talking about here. Then we'll find the mean of the numbers we just did. It sounds kind of complicated. It looks kind of complicated. Let's go do it. Bonnie surveyed 6 classmates about the number of hours of TV they watched each week. And these are the responses she got. What is the mean absolute deviation of the data set? First, we have to find the mean of the data set. Add up 6 plus 7.5 plus 4 plus 10 plus 13.5 plus 7. We get 48, and we're going to divide it by the number of numbers we have, which is 6, and we're going to get 8. So the mean of our data set is 8. Organize the work into a table. Tables will help us keep organized and make it easier for us to calculate our MAD. Write the data values from Bonnie's survey in order to keep them more organized. So here's a table for us. We've got average TV hours on the left over here, how far they are from the mean over here, and their absolute deviation over here. Notice they are in order, starting from the top and going up as we go down. So they're 4, 6, 7, 7.5, 10, 13.5. Also, you notice that some of the deviations over here are negative. If you need a calculator to determine negatives, that's fine. If you can do it on a number line, remember subtracting, you're moving to the left. That's also fine. Some of them are going to be negative, and that's fine. They are smaller than the mean. If it's negative, that means that they are smaller from the mean. If you're looking at the mean on a number line, they're to the left. How far, the question you're looking for is how far to the left are they, which is why we have the absolute value of each deviation. So now we have a bunch of absolute deviations. Okay, notice that as we go down, the numbers get smaller, and then they start getting bigger again. The closer we get to the mean, the smaller the number gets. The farther away from the mean we get, the larger the number gets. Now we need to find the mean of these values here. 4 plus 2 plus 1 plus 0.5 plus 2 plus 5.5 is 15. We're going to divide that by the number of numbers, which is 6, and we end up with 2.5, which means that the average distance of our numbers is 2.5 from the mean, which means our data set's not terribly spread out. We've got a fairly small data set, fairly clumped data set. What does it mean? On average, the number of hours that students watch TV per week is about within 2.5 hours of the mean. So yes, we have our mean, which is the average, but the average number of TV hours that the students are watching per week is within 2.5 hours of that mean. Is there another slide? Apparently there's not another slide to tell us that there is an assignment on Google Classroom for you to work on